Okay, guys, so we are looking at section 1.4, part 4. Here's our learning target. We're trying to find constants to form continuous functions. And the other thing we're going to look at is the intermediate value theorem and how to use it. So here's an example of how to create a function that would be continuous over the function. To be continuous, I have to be able to trace it without lifting my pen. So for this function, we're told the first part of the piecewise function is y equals 3x squared when x is less than or equal to 2. I want to know, what does this a value need to be to make this continuous? Does anybody have any ideas of what we could do there? We want to create a continuous function. What do I get if I plug 2 into this function? 12, right? So when I plug in 2, I get 12. Wouldn't we want this to have the same result to make it continuous? In other words, if I plug in 2 for x, it's going to have to be 12 in order for me to have a continuous function. How could I make that happen? Is there an equation I could solve? Do you have it? Plug in 7? Why would you plug in 7? Oh, I gotcha. Okay, so what you're saying then is my y value is 12, and I'm trying to figure out what a is. X is 2, and then minus 2. So we're plugging in 2 for x, and we want our answer to be 12. And she's saying if we plug in 7, that's going to make it happen, isn't it? So basically she's solving this equation. 12 equals 2a minus 2, so 14 equals 2a, and so therefore a would have to be 7. She's right. Okay? So to create a continuous function, we just have to get the same result. So we want to know what a value is going to make it so that when we plug in 2, we get 12. All right? And that would make it continuous. Just to review this with you, let's say I wanted to check it. I go to my y equals. You don't have to put this in, just watch, unless you want to practice. So I put in 3x squared. I say divide it up. Only do this when x is less than or equal to 12. And then I'm going to say, okay, put in, she said a is 7. So put in 7x minus 2. Divide it up though. Only graph this. Hold on, I put in 12. But only graph this when x is greater than 2. Okay, see what I'm doing? Now I want to see, is this a continuous function? And I'm not going to see up there at 12. I'm going to have to make my graph go higher. Okay, so here's the function, the first part of it, and then here's the second part of it. Now, it doesn't really look connected, but that's kind of a glitch in the program. That's because it's starting at the next integer. Let me see if I could fix that. I'm going to make this, we're just going to make it greater than 1.9 so that maybe that won't happen. Let's see. Yeah, there we go. Do you see what it's doing though? It's starting at the next integer, which it really shouldn't do. It should start at 2.00001, but it doesn't. It's kind of like a problem with the programming. All right, but there we go. That's going to work. Okay, a lot harder problem here. So this is saying that we're graphing this function. Let me even do a picture of this for you. So when we're looking at -2, if our x value is less than or equal to -2, we're plotting the line y equals 3. Looks like that. If x is greater than or equal to 1, we're graphing the line -3. So I know this first part, I'd have y equals 3 until I get to -2. Then I have this, which I don't know what a and b are. We've got to figure that out. Then we've got -3 when x is greater than or equal to 1. So here's 1, -3. So the question is, what do a and b need to be to make this a continuous function? Any ideas? What would A be the same as if I look at this line right here? A would be the same as the what? Slope, right? Okay, so I know then that A, I know this point here. What's this point here? Negative 2 what? What's this point? So if I can find the slope, that's going to be equal to A. So I can do A is going to be negative 3 minus 3 over 1 minus negative 2. That's negative 6 over 3, so the slope's going to have to be negative 2. So I know what A is. A has to be negative 2. Well, now what could I do once I know what A is? Think about it, guys. I'm looking at this part of the function. I've got, here's what I'm left with basically. Y equals AX plus B. I just need to know what B is, right? How can I find B once I know what A is? Who said it? Leah, did you say it? Okay. Yeah, plug in. I can plug in for A. I can plug in for X and Y. Right? I can plug in for, because I know the A value and I know X and Y. I can use either one of these 2 points. I'll choose that point. So now I can plug in 3 for Y. A we know is negative 2. X we know is negative 2 plus B. That's going to allow us to find out what B is. Solve that and tell me what you get for B. Morgan, what'd you get? It is. Okay, so therefore now we know A has to be negative 2 and B has to be negative 1. And that's what we were trying to do, was find A and B. In this case, we didn't have a B, so we just had to find A. So here's our A, here's our B. Okay? You'll have to do something like that on your homework. Intermediate value theorem says this. If we have a continuous function on the closed interval from A to B, and K is any number between f of A and f of B. So it's saying Y values here. Y is some value between the Y value when we plug in A and the Y value when we plug in B. Then there is at least one number over this interval, C, such that f of C equals K. Another abstract concept. Here's what it's saying. If I get a certain result, right, that's in between the results of plugging in A and B, then there has to be a C that makes it true. All right, let me come down here and make it more concrete. Here's our function. Here's our interval. We're saying over this interval, there has to be some C that makes our answer 4. So where am I going to plug in the 4? For f of x or for x? Which one? F of C, does that mean an x value or a y value? Y value. So I'm going to plug this in for y. So here's y, plug it in. I'm trying to solve for C, so I'm going to plug in C for x. That's what I'm trying to solve. I'm trying to find what is the C value that makes this true. How can we solve this? Get a set equal to what? 0. Get a set equal to 0. So 0 equals C squared plus 4C minus 12. Set up your double parentheses, C and C. What are numbers that multiply to be 12 and subtract to be 4? 6 and 2. We need to get a positive 4. So which one's positive? 6, this is negative. So our solution then is C could be negative 6 or positive 2. One of those is not our answer. One is. Look at the restriction here. This is our interval. We're looking for a C in between 0 and 6. So what's our answer then going to be for 6? Or for C? 2. Our answer for C is 2 because that's in between 0 and 6. Okay? All right, so where am I going to plug in the 8 here? Plug it in for what? Y. So in for Y goes the 8. So to solve this then, I'm going to have to cross multiply. That's how I solve a problem like this. I'm going to multiply these and I'm going to multiply these. So I'm going to get x squared plus 2x equals 8x minus 8. You have to make sure you multiply the whole thing. So then we're going to have x squared plus, actually minus 6x plus 8 equals 0. I'm just getting it set equal to 0 so I can factor it. What are numbers that multiply to be 8 and add to be 6? 2 and 4. So I'm going to have x and x, minus 4 and minus 2. So the solutions I get are x equals 4 and x equals 2. But which one of these is going to be the solution? Which C value, I should be using C actually, it's going to have to be 4. So I would say my answer then is C equals 4. The reason I'm calling it C is because it says f of C has to be 8. What is C? And the only value here, 2 and 4, that's in between 3 and 10, is the 4, not the 2. Okay? All right, why don't you just watch the next part? You don't even really need to write anything down. Just watch. I'm getting rid of the chart. That's abstract. Let's go to this instead. Find x values where f is not continuous. Our first function, f equals x minus 4 over x squared minus 8x plus 16. I want to know, where is it not continuous? What should we do first, guys? Factor. Yes, somebody whispered that. So when I do that, I get this. So these are now going to cancel, which you would think would mean we have a hole in the graph at 4, right? But what happens still? We still have a vertical asymptote, right? So we would have a hole in the graph if that was the only thing that happened, but we still have this. So this is going to result in a vertical asymptote, also known as a non-removable discontinuity at x equals 4. Does that make sense? Non-removable. It's going to be a vertical asymptote. All right, what about this one? Do you remember what this graph looks like? Grace, what's it look like?
It's going to be 2 lines, and they're going to be 1 and negative 1 at positive 4x.
Good job. So this is going to be negative 1 here, and then it jumps up to positive 1 here. So that's the way it looks like. What would we say about the continuity there? Is that removable or non-removable? Non-removable, right? Even if I fill in the dots. So non-removable discontinuity, again, at x equals 4. All right. Last thing you're going to have to do is describe the intervals where this function is continuous. And the function is tangent of pi x over 2. Do you guys know what the period is for tangent normally? It's normally pi, yeah. For sine, cosine, secant, cosecant, the period is 2 pi. But for tangent and cotangent, normally the period is pi over b. Normally we don't have a b value, but now we do. So my period then is going to have to be pi divided by, here's my b value. My b value is actually going to be 2 over pi. This is going to get kind of strange, but here's the reason why. Because b is, well, actually b is going to be the coefficient of x. So b is going to be pi over 2. So we're going to have to do pi divided by pi over 2. What is pi divided by pi over 2? Nope. It'd be pi times 2 over pi. What's that going to be? Just 2. So now the period's going to be 2. This gets kind of complicated. Here's what's going to happen with this then. The tangent graph always looks like this. And normally the asymptotes are at negative pi over 2 and positive pi over 2. But where are the asymptotes going to be now? Like this is when the period's pi. If the period's 2, where would these vertical asymptotes be? The period's 2 now. When the period's pi, they're at negative pi over 2 and pi over 2. If the period's 2, they're going to be at, it has to split it, guys. Here are the period's pi, it splits it in half. Here are the period's 2, so where are these going to be, these asymptotes? You got it. 1 and negative 1. That's where the asymptotes are going to be. And then another 2 units. At 3, I'd have 1. Back 2 units. At negative 3, here's where all my asymptotes are going to go. Let's say I don't know that. I'm like, okay, this is confusing, which it is. It's a hard problem. I can just put this in my calculator. Tangent of pi over 2x. That would be okay. It's not going to divide by 2x. It still knows that's a coefficient. Zoom trig. See how it looks like that? I can look at my table to find out where those asymptotes are. So those asymptotes are at negative 1, 1, 3, 5. You see what I'm saying? Like I can use that to find those asymptotes. So the way I would write where the intervals where it's continuous, it's going to be continuous if x is not equal to, I can choose 1 or negative 1, 1 plus 2k, where k is an integer. It's going to be continuous as long as x is not equal to 1 plus 2k. If I want to write it out in interval notation, I can do this, dot, dot, dot. Negative 3 to negative 1, continuous. Negative 1 to 1, continuous. 1 to 3, continuous, dot, dot, dot. And see how we can see the pattern there? Goes on forever like that. Okay? That's the toughest problem you'll see on your homework, is that kind of problem. All right, guys, so that's it. Your assignment, I'll put up here. It's also on Canvas. It's out of the book today.